Today, I'm speaking with Dr. Adrian Chase, an archaeologist and expert on the ancient Maya. He currently has a postdoctoral appointment with the Mansueto Institute for Urban Innovation and the Department of Anthropology at the University of Chicago. Adrian combines remote sensing, on-the-ground fieldwork, and computational methods to understanding Maya urbanism, and has spent many years studying the ancient city of Caracol, located in modern-day Belize. In our discussion, we take a deep dive into the process of mapping and understanding ancient cities, how the Maya shaped the natural world around them, and how Maya urbanism can enrich our understanding of modern cities. My name is Sebastian Weatherby, and this is The Tell. Hi, Adrian. Thanks for talking with me.
Hi, Sebastian. Thank you for having me.
I took a photo of the name of the building that I was waiting outside of to meet you. The Institute for Mathematical and Statistical Innovation and the Mansueto Institute for Urban Innovation. This is not the corner of campus that I normally find archaeologists. There's classics buildings, there's humanities buildings. I wanted to ask about your background in the more STEM statistical side of academia.
No, that's a good question. And actually, so the institute that I'm affiliated with here is the Mansueto Institute for Urban Innovation, which by its nature is supposed to be this collection of different scholars from any field that studies cities.
Yeah.
So they've actually had archaeologists before. I'm sort of the only archaeologist now as the current set of postdocs, but we have geography, social science represented, economics, a couple different people who are sort of more public policy oriented. And the goal for most of them is to look at modern cities and modern urban data. And then the goal of having somebody with my background to say, well, how far back into the past can we look? Can we start to use other data sets? Can we go into the historic or maybe the archaeological data? Because it's all well and good that you can see a pattern today in this current sample from the, let's say, 2020 census. Maybe you can see it in the 2000 census.
Yeah.
Maybe you can see it if you go far enough back into one of the 1800s censuses. But can you see that in historic or ancient city data?
And why the Maya in particular? Because you could be studying cities in Italy or Turkey or all over.
So the former archaeologist was a Mediterranean scholar who works in Turkey specifically. And one of the tricks is those old world cities have this sort of form where it's very von Thunen, right? There's the city center, and then you go out and you find agriculture, and then you find sort of pastoral landscapes. Now, for the Maya, we don't have beasts of burden or horses in the New World until they're introduced after Europeans come in. And so you have these cities and settlements where some of them look like that. So they have that same dense urban core surrounded by fields.
Those concentric
but you don't have the
circles
pastoral animals because they're not present. And you don't really have the wheel except in children's toys, so people are moving by foot or by canoe. But for Maya cities like Caracol, it's this massive city that covers probably 240 square kilometers, about 200 of that in Belize, an additional 40 maybe in Guatemala. It has about 25 different district centers distributed over that landscape. Each of those has like a public plaza, some administrative buildings. They're connected by a dendritic causeway system, dendritic meaning that everything is connected into the downtown city center. So the goal is kind of like the L system in Chicago. It's to move people to and from the core. It's less to help you move from side to side within those outlying nodes.
Right.
Now, within that large landscape, there are probably over 100,000 people conservatively, at the city's peak around 700. But what they've done is as soon as you step off of the downtown, you're immediately in agricultural terracing. You're immediately in this garden city, this sort of green landscape. So that 200 square kilometers doesn't necessarily look urban to an archaeologist who studied in the old world. And there are a couple other places where this has been found. Often it's in the tropics. And what we're doing is when we're these urban archaeologists working in tropical landscapes, we're pushing back against this old narrative that sort of the jungle is useless land. So there's this old British report talking about the Vaca Plateau, the sort of geologic area where Caracol is situated, where the Brits determined that in their colony of British Honduras, modern-day Belize, the only economically viable activity would have been cattle farming, maybe. Now, this is in a region where, in the past, the city of Caracol is actually larger than the current largest city in Belize today, Belize City.
Wow, that's pretty wild.
But Belize City is much denser because it's like that.
It's more of that
core,
kind of Eurasian urban pattern.
And one of the talk I actually gave here at Mansueto a couple weeks ago is focused on urban services on that landscape and how reachable they were. And what I can basically say is that ancient Caracol, even with this sort of distributed set of different districts with urban services, so the public plazas where you could have social interactions, political rallies, processions, ritual events, sort of, it's a formalized paved public space that can serve just about any purpose. You also have the ball courts for playing the Mesoamerican ball game, and e-groups, which are these early community features. And all of those are, e-groups. So it's named after the e-group at Washaktun. And it's this style where it's a long linear building on the eastern side and then a larger western structure. Often there then is either a single large central structure on that linear building or three. And there are other versions and modifications. But those are built pretty early, and they actually tend to precede rulership, which is a whole separate topic. Takeshi Inamata has done a lot of cool research showing this form within his larger units, sort of at Aguada Phoenix and other centers. And I'm looking forward to seeing that research kind of move forward. Jumping back, though, to the landscape of movement, it's sort of about a 25-minute walk to the nearest public plaza, 20-minute walk to the nearest public plaza, about 25 minutes to ball court, and about 50 minutes to an e-group. And all of that falls within modern commuting times, too. There's some there's some old analysis looking at European cities from an anthropological perspective, especially Berlin. I forget the scholar off the top of my head. But what he was showing is as people moved from walking to traveling by horse to automobiles, the average time to get to the downtown was about 30 minutes. But the distance of the city expanded over time. So this idea that the commuting distance is sort of a common. And I found some ethnohistoric data reported by Paula Sabloff for the island of Cozumel, where she shows that the farmers were willing to live in a dense town and then walk up to an hour to get to their fields. So they were willing to do a daily commute in reverse. So instead of going to the downtown, from the downtown.
Get out of the downtown,
And after that hour distance, it's sort of between an hour and 2 hours, they started to build outbuildings and sort of field houses. So what happened is if you had a field that was maybe 2 hours away, you'd do that walk an hour and a half, you'd spend a couple of days in that other house tending the field, and then come back to town.
How did you get your start doing Maya archaeology?
So in that I actually have a bit of a weird story, right? Because
I kind of wondered about this, because I noticed names on a few of your papers.
So my first field season technically was at 2 months old when I went to Caracol with my parents. So I grew up kind of as a field brat. And I've been around archaeology that whole time. My siblings and I would all get to go to the field through our public school education. And we'd be homeschooled for that part of the year we were in the field and then reintegrate back into the U.S. system. Because the Caracol season is in springtime. So that's sort of February, March.
When it's least hot and humid.
It's actually the rain, right? So if we did a summer field season, you can't always get to Caracol, especially when the road was really cruddy. So the road used to be this sort of dirt road going about 50 miles to the nearest town, San Ignacio. And if there was a heavy rain, that road just turns into a slog. And there were parts of it where trucks would be flipped or run off-road. There's a really good picture of a truck that's sort of, or more like a Jeep, that's kind of sunk up to its doors in mud, which is funny from this perspective of not being the person who was in the car or driving it, you know? Belize is currently paving that road, so there's going to be this future where that isn't an issue.
And did you kind of always growing up know that you were going to follow in your parents' footsteps? And
So I think initially all of us started off very inquisitive. I did a bit of like science fair in middle and high school, and there I was actually focused more on microbiology. A lot of that was that in microbiology, right, you have your little petri dish and you can test things on bacteria, and bacteria have a generation once every like 20 minutes on average. So you could get several generations worth of results in a single evening or overnight. So there was this really cool pace of research where you could do something and immediately see the result the next day. Whereas for archaeology, let's say you put in a grant and you want to test a neighborhood. That neighborhood project could be multiple years of investigation.
There's a glacial pace to things,
So at Caracol, maybe we sample about 3 households, 3 plazuela groups each year. And you can think about the sampling as focusing on the eastern structure, which tends to have caches and burial deposits, things that are datable to help give us a sort of chronology of settlement. But that's just like one structure within the Plazuela, and that's just maybe 3 of those plus some other excavations in the Plazuelas each season. So if you want to sample a neighborhood that could have, let's say, 10 households, that's at least 3 years of work.
And sampling a household at a site like Caracol, you had an awesome analogy just before we turned the mics on, if you don't mind sharing it again.
Yeah, so I think the way to think about this is Caracol is immense. So one of the things that the LiDAR data has really allowed is to look at the whole city in a way that would be much, much more expensive if you had to do it on foot. So if you had to cut breaches, it would take decades to recreate this same sort of survey data set. At the same time, you can imagine if you're sampling a city that had over 100,000 people, and let's assume it's 10 people per Plazuela group. So here I'm using Plazuela. It turns out the term was actually defined for the Caracol region. J. Eric S. Thompson in the 1930s, when he did his excavations at Mountain Cow. Turns out Mountain Cow is in Caracol. It's 2 of the districts, Hatzcapquil and Cajalpachik, and then 2 of its neighborhoods. So the Plazuela was named for this unit where you had a central flat plaza with structures around it, often 4, situated roughly cardinally. They're not exact, I can say that for certain, but that unit occurs at Caracol and it occurs elsewhere. But I've been using it and not realized until recently that it actually originated from Thompson looking at the households at Caracol.
Yeah.
So that unit with the multiple structures, it could have up to 18 that are visible. It could just be that they're stone-lined around that sort of paved plaza area, and they would have been sort of pole and thatch. But they would have housed an extended family group. And based on sort of ethnography, ethnohistory, probably 10. So it could be anywhere from maybe 5 to 20 people from the actual sample, but we use 10 as that more conservative estimate. So if you take 100,000, 10 per, you probably have about 10,000 Plazuelas in that landscape. And so if you imagine you're sampling 3 per year, that's a very small fraction. So in contrast, if you were to take a modern city like Chicago or Phoenix, LA, London, and you could imagine that you can investigate 3 apartments or 3 single standing households each season, and you don't get to excavate the whole thing. You have to pick which room you're sampling. It would take a long time to actually understand what's going on.
Which I suppose is what led you to LiDAR as such a powerful tool. And I'd imagine a lot of people listening with a general interest in ancient history, they've probably seen a couple of Nat Geo articles by now, whole cities emerging out of the rainforest, neon-colored images of like the pyramids and plazas from the air. But could you talk a bit about, for those who may not know, what LiDAR is and sort of what it does for you?
Yeah, so I think I'll take like a step back, and what it is you're shooting a laser beam, right? And you're doing this a lot. So if you imagine a single LiDAR shot, you take the laser and you fire it, and you know the speed of light, so you can measure the time it takes for the laser to bounce back. So you're looking at that distance in terms of reflected light. But as the laser travels, it actually kind of widens a little bit, so you would tend to get this sort of pattern of partial returns. And in the data I work with at Caracol and some of the older data, what you'll see is sort of up to 4 peaks in those returns. So you can imagine you get the first peak when you hit the upper leaves and tree canopy. And as you hit different parts of the canopy, you get other returns that are points.
And so that's kind of the value of it also, is that peeling back of the canopy.
Exactly. So what you want is that like final layer of returns, that point that takes the longest to come back. And theoretically, that's the ground floor. And the way that this laser was actually initially used was to measure water vapor in clouds. So the laser gets absorbed by water, which means that, so there are different frequencies now that can penetrate sort of bathymetric LiDAR and go within water, but for the data that we have. So for the reservoirs that are still holding water, they look like these big gaping holes in the data set, because the laser light hits the water and it absorbs the energy and doesn't re-emit it. But it also means that you want to fly in the dry season, when it's less wet.
That makes sense,
And when the trees have as little vegetation as possible.
So you're kind of timing your work for optimum conditions.
Exactly. And so that's why you'll see all the LiDAR flights tend to happen in June and July in those regions, and sort of trying to time it around that rainy season.
Could I ask you about your work studying water management and reservoirs? Because that, from what you said earlier to me, is kind of how you got your start in research. What got you interested in that?
No, thank you. That's a great question. So actually, it starts a little personal, right? So we'd have a project of maybe 20 people, and we're in the middle of Caracol, the city center, which could have held at least 10,000 people for that same district, right? And we can run out of water. But the ancient Maya who were there didn't have the capability of getting a truck to come bring water up from the river.
Right.
So in theory, they really can't run out of water because they die of thirst. So instead, it's a question of, well, how is the water situated? There are these large reservoirs in the downtown cores, a couple of them, but then there are also all these household reservoirs. And what got me interested is, well, we run out of water. What did the ancient Maya do? Because it would have been harder for them to run out of water than it is for us.
Yeah, reliance on rainfall, especially for a densely populated agrarian society, that definitely seems like life on a knife edge.
Yeah, well, and I think that's part of the reason they spent so much effort transforming that landscape. So it's not just the residential reservoirs that they're building, the paved surfaces of those plazuelas, the households.
Yeah.
Those are designed so that they're funneling clean water into the reservoirs, which are often located just off the edge of the house.
Yeah, yeah.
But then they also have agriculture. So most of it, probably 160 square kilometers in Belize, is dedicated to agricultural production on those terraces. But the terraces are designed to direct the flow of water, so they're stopping a little bit of soil erosion, which is the traditional role that people describe and ascribe to terraces historically in the literature. But they're also designed so that they help keep water in that sort of root reservoir zone. And so you can imagine after heavy rain, the terrace soils get saturated. The wall is designed so it doesn't burst as the soil expands due to the addition of this extra water. And over time, it's slowing the flow of water on the surface, and then it's slowing the flow of water sort of along that bedrock zone. So you get this long time span where the water can kind of sits around.
Yeah.
And you have to do a trade-off, right? Because if you have too much water, then the roots rot and they don't get enough oxygen. And if you don't have enough water, then your plants don't grow.
Right, right.
So it's a hydrologically well-designed city. And I do mean hydrologic in terms of rainfall and just normal water. We don't have any sign of water pressure for Caracol.
Could you outline sort of the chronology of Caracol, just the broad brushstrokes sort of temporally of what periods we're dealing with?
So if you're thinking about this region, so within Caracol, initial settlement based on what we've excavated, the oldest household. It's sort of near this district of Monterey, and the house itself is sort of situated along the main axis of what's now the main east-west causeway that goes from Caracol to Hatzcapquil and Cajalpachik. And that would date to 600 BCE based on its oldest deposit. So there probably are older houses, there's possibly more settlement, but there's initial people moving in and settling by 600. And by 360, I believe, BCE, you see the creation of these E-groups at different centers. So 360, you get the E-group in downtown Caracol.
Yeah.
It's in a very early form where it's mostly the platform with the western structure, and it gets added to over time. But what that suggests is you now have people who are working together. They organize collectively in some way to build this structure. And the E-groups are traditionally ascribed to, the old model was astronomical alignment. The newer model is that it's used to measure sort of a period of 260 days.
Okay.
Because they're not perfectly aligned.
Yeah, yeah.
And often what they're concerned about is the two edges, and sometimes they're actually aligned with features on the landscape. So instead it might be that there's a sacred site on that hill over there. But these early features are built at 360 BC, and then we don't have evidence of rulership at Caracol until 331 CE.
Oh, really? Okay.
So almost 700 years later.
Wow.
And within that time, before the ruler emerges, they've already put this east-west causeway in. They've sort of formed a city with multiple district cores.
Yeah.
And the city initially expands by conurbating. It grows into adjacent urban settlements, and the two grow together, and then they sort of fuse. So you can picture Caracol kind of running like we think of a modern city today. There was a talk by one of my colleagues here yesterday looking at Boston, and one of the funny things is if we think of Boston informally, not looking at the political data, we're going to put Cambridge and we're going to put other cities into like this greater Boston sphere.
Yeah, these sort of greater metro areas.
But that's not technically the data set for Boston proper.
Yeah, yeah, yeah.
And so for Caracol, it's probably running into that same kind of issue, where we need their actual records to say this is exactly where the boundary is. And I've done my best to reconstruct those with sort of least cost paths and other cost distance modifiers.
Yeah, yeah.
But yeah, the city grows, it sort of has a ruler who emerges. Those early rulers are sometimes just sort of the people of the Three Stone Place. So the title isn't always the ahau. And it takes until later where they introduce the sort of second emblem glyph for the site.
Oh, interesting.
Ku'ul Kantumak, the divine holy person of the Kantu place, basically. And that one comes in with sort of the three most powerful rulers at Caracol, and this is getting much, much later. So basically it's that period before 680, but it's after you start to have scuffles between Lord Water at Caracol, where initially Caracol is probably in some subordinate relationship with Tikal. The Caracol royal family is probably related to those at Tikal at this point. They have some common ancestor way back in time, maybe that 331 date. At 330, there's also a fun thing where there's a Teotihuacan burial that could date to 300 to 350. Yeah. That's cool. Right next to Kana in the northeast Acropolis. But that's a separate topic about Teo's influence in the Maya area. So you have initial Lord Water, there's an event, this axe event, and then eventually there's a series of conflicts with Tikal. And a lot of this gets described by Lord Water's son, or potential son, Khan II. And he's ascribing Lord Water victory over Tikal and his own victory over Naranjo, which is sort of this major bulwark altar from Caracol. It contains this history. And then Khan II is probably governing actually from Naranjo after that point because it's along the Belize River. And he's controlling all the east-west trade that's going through from a top-down level. And at this period at Caracol, the population starts spiking. They're seeing returns from success in warfare. And then the third ruler we know very little about, but when he's dethroned in 680, you'd think that Caracol would suddenly go into this decline because it's a period where the rulers have been defeated, they've been sort of kicked out. Yeah. We have a hieroglyphic hiatus. We don't really know much about the royal family or what's happening. There are people living on Kana, but they're not writing about what they're doing. But instead what we see is that like period from 680 to sort of 800, 780, Caracol is doing incredibly well for itself. If you're an average person, that's the point in time where you'd want to live at Caracol instead of the preceding or the subsequent periods. Yeah. So they get access to long-distance trade goods. They have ocean shell. They're getting ocean fish, jadeite within the household context. Everyone has access to obsidian. Wow. And the elites are not exhibiting the same amount of wealth that they do in the subsequent period. So there's almost this sense of sort of pushing up the group of people in the middle.
And does Caracol experience a significant decline after the Classic period?
So yeah. So after this period where it seems like there's this symbolic egalitarianism where everybody's really doing well, the rulers come back, and then suddenly there's a system of haves and have-nots, and it appears that people start to very quickly leave. Oh, interesting. So there's a period where the population is declining for about 100 years, and towards the end of that, there are sort of evidence of sort of burning of the downtown. And then after that, we assume everybody leaves pretty quickly.
In all of sort of the debates over the post-classic decline regionally in the lowlands, among the factors that gets mentioned is drought and water management. And I sort of thought of Lamini while you were talking about Caracol's water management and how being situated on the New River Lagoon, they didn't have the same kind of environmental vulnerability. Do you think that that played into the events at Caracol in any way?
Yeah, so it's probably not just one factor, but multi-causal. Yeah. So in that period, basically from 700 to, let's say, 1,000, you have different centers kind of disappearing. And you can imagine that they're not just that people are moving away, but as they do that, they're popping out of the trade network. So you have this sort of systematic collapse happening, which would make it harder to get some materials. In terms of drought, there's some evidence for a bit of drought with different climatic records, although that period is still wetter than modern day, is my understanding.
Oh, interesting. Okay.
So there's some weirdness there. And you can also see that some of the political events, like the burning of the downtown, would probably have really drastic, sudden consequences. But I feel like the major thing that leads to the decline of Caracol is probably this bifurcation that happens in that last 100 years between the haves and have-nots. So there's a huge social motivation that is probably exacerbated by climatic drought, trade, and other factors.
Yeah, and what is that, the Gini coefficient? Or?
So yeah, one of the ways we can measure that is the Gini coefficient. So it's a data simplification method, but it gives you a sense of how equally resources are divided among the whole population. So if everybody has the same amount of stuff, the relationship looks linear on a graph, and you get a Gini coefficient of 0. But let's say nobody has anything and one person owns all the land, that's when you get a Gini coefficient of 1. And you can imagine that graph where the line that's sort of x equals y that goes up the middle, that diagonal, that 45 degrees, the difference between that and the line that follows right along the x-axis until the last person
suddenly as an asymptote.
Yep. Yeah. So that area is the one measure. And so what happens is when you see that Lorenz curve plotted, the Gini is actually the relationship of those two areas.
Okay. Yeah.
So it's actually calculus, but we often can get away with just doing like a Riemann sums with an Excel sheet.
How did you move from looking at water management and some of these initial questions you had as you kind of stepped into being a researcher to where you are now? What was your path of questions that you were asking, I suppose?
No, thank you. That's a good question. So I started with water, right? And then I entered grad school. And so the question then becomes less about do they have enough water, because the answer seemed to be yes, and instead, how was the water administered? What was the sense of governance? And that led me into this tangent of looking at water management more broadly, in particular sort of Eleanor Ostrom and her work on small communities self-organizing for water management or management of other common resources over time. Where she's reacting to Hardin's work, that Tragedy of the Commons.
Garrett Hardin, yeah. And there's definitely been a lot of work, particularly in the last couple decades, starting to demonstrate that there's numerous examples of people solving the tragedy of the commons in a sense.
Right, and Eleanor Ostrom, that was sort of her life goal as an economist, is if you have a small enough group of people, they can manage things locally through social norms, through sort of behavior where the group says, hey, you've been using too much water, you need to tone it down, or we'll
the establishment of
inviting you to
taboos
things. And that gets translated then into different ways in archaeology where you have, well, another fun one is sort of that Priests and Programmers by Lansing, where he talks about the water temples in Bali. And so you have a political system totally separate from the water management system, where the priests are there to sort of tell people when to plant and what to do and to allocate water resources. And then when the Green Revolution comes in, they give everybody fertilizers, they tell them they can plant whatever, and then pest populations spike. And there's a little bit of evidence that some of those social and cultural norms that were in place were beneficial for the farmers.
And so when you're trying to trace who's managing the water, what kind of a structure there is to that, what are you actually doing in terms of what are you mapping? And
so there it starts by looking at the sort of large resources that are able to be controlled and to look for evidence of, is there evidence that they were sort of controlled? Are there walls around it? Are there monitoring stations? Is there a sense that you could actually restrict access? And at Caracol, there really doesn't appear to be, but there's also much more labor invested in those residential reservoirs over time. So it led to this focus on sort of that household labor pool and more local management. But they do have some large reservoirs. Those largest do tend to be at the earliest centers, at which point they may have been established either to help provision water or maybe just to help cover all the water costs for replastering everything, because plaster tends to eat a bit of water too. We're usually talking about drinking water, but when you have water, you can use it for whatever you need the water for. But what that led me to is looking at governments more broadly. So not just water, but other resources, how public plaza access, where are the ball courts located, was the city designed to provide services to its residents more broadly? And this is getting it now to sort of bifurcate from this Whitfogelian idea of the elite control water, and that's why they're the elite, toward one of public services and this sort of bureaucracy running things.
To what degree do you think this kind of organization would have been sort of centrally planned versus what would you say being a little more sort of distributed or self-organized?
So in terms of looking at centrally planned and self-organized systems, there's this sort of interesting dichotomy where you can think of it as top-down and bottom-up, but you could look at that at different levels. So what does it look like if you're top-down at the household level? The neighborhood structure would be top-down, the district would be top-down, and any centralized city planning would be top-down. But you could imagine a situation where now the neighborhoods are self-organizing from a bottom-up fashion to push for change at a different level above them.
Right,
And so within Caracol, there's from the city level, looking at that city scale, the distribution of those different public plazas and other services suggest a more decentralized bottom-up organization. But within each district, those resources are centralized into one district node.
So you have a little bit of fractal sort of pattern almost.
Yeah, exactly. And fractal's sort of a neat way to think about it. Instead, there's also this Gutman scale, if you will. It's a little bit different than a true Gutman scale, but at every node where you have an E-group, you also have a ball court.
Yeah.
And when you have a ball court, you always have a public plaza, but the reverse is not true. So you have many more public plazas than you have ball courts, many more ball courts than you have E-groups. But when you have one, you always have the others. So there's this sort of centralization of certain resources versus others.
Okay.
Or services, rather.
Yeah.
Because I'm viewing these as architectural features that you can identify pretty clearly from the LiDAR data and add to it with archaeological excavation. But a ball court always looks like a ball court, where you have those two linear structures and sort of the court in the middle. So you can pick it out without having to actually go there necessarily.
And is there a diachronic sort of element to this endeavor? Are you looking for change across time in the city?
Yeah, so one of the tricks, right, is you could imagine if you sort of had a timeless system, that you'd see that sort of hexagonal pattern that you'd expect from like Trigger or Von Thunen or sort of other models of these concentric rings building on each other. But instead, there's some history. So at Caracol, that history is the initial conurbation between downtown Caracol, Hatskapkil, and Kahalpachik, which immediately gives the city this east-west focus. And they put in this causeway, which they build from two ends, because they one end turns a little too fast, and the other has to turn to catch up. So there's this little loop where they go uphill where they didn't have to. And they continue to use that, let's say, for almost 1,000 years.
Yeah.
And no one thinks, let's go rebuild the causeway. So once the infrastructure is in place, people continue to use it, which has implications today, too. But that initial conurbation between the three nodes, you could picture that as sort of a mini version of like the Aztec Triple Alliance. You know how...
Right, yeah.
Yeah, three different centers with their own sets of elite and personal relationships.
But suddenly they've kind of bled into each other, and then now they need to integrate, and there needs to... Right.
And they have to work together.
Yeah, yeah.
And so, and also that sort of sense of like state politics, where if somebody gets a little too powerful, the other two might work together to pull them back down.
Yeah.
And you can picture that happening maybe for that 700-year span where you have the E-groups, but you don't have the ruler emerge, and then suddenly a ruler emerges. And at that point, everything consolidates on the downtown as the central one of those three nodes.
Oh, interesting. So there is a pretty quick sort of, you can see the ripple effects of that.
So over the long term. So initially, there probably isn't too much change, but what it leads to is that over time, more architecture and larger houses tend to gravitate a little more toward the downtown node. And then the causeway system is built radiating out mostly from the downtown. There are a couple radiating out from the other two nodes to the east, but the focus shifts, and then as the causeway network gets put in place, you can see that as a natural attractor.
Yeah.
Where you'd want to follow the causeway. These are not super elevated causeways. You could get on and off throughout the whole system, and they're mostly running from district to district. There are a few little spurs and other little weird bits, and there's a bypass that connects two of the southern causeways across a terrace system. But fundamentally, they're navigating most of the traffic to the downtown. And if you have to go from the eastern to western side, you're probably then being rerouted through downtown Caracol, Kahalpachik, and Hatskapkil.
Is this still sort of your current arc of research, or do you have kind of new emerging questions?
Yeah, so some of this is still current. I'm still looking at the urban services and how they're provisioned, but I'm also trying to apply some more of the Mansueto techniques to it. And in particular, one of my two advisors here, Luis Battencourt, who runs the Institute, his focus has been on this idea of urban scaling. And what you can think of this is that bigger cities don't just have more of a thing. They have more of a thing in a ratio that's sort of explorable. So it's not just that a bigger city has more rock bands, it has more rock bands per person. So it's an exponential growth.
Yeah.
But it also has an exponential savings. There are fewer streets per person because now you can just add a little avenue coming out from the existing street network.
So it's like an increasing efficiency in a way of like more specialization, more things per capita, less cost per capita, that kind of thing?
Right. So the idea is that you have a city where there are certain things that you're getting savings on, like infrastructure.
Yeah.
So that's sublinear scaling.
Yeah.
There's certain things where you're getting an exact return because every additional person has to eat.
Right.
So that's linear.
Right.
And then there's some things that are super linear, where you're getting that efficiency bonus. And you can think of that as number of interactions, firms, rock bands, but also negatives like amount of crime.
Right.
So they're some penalties in that, and you can picture sort of the limits on city sizes. Once you put too many people too close together, there are negative externalities that outweigh the positive benefits. But this is looking at those relationships at a large scale, but often at the upper end of city sizes.
How does it work to trace this stuff via the LiDAR data? Like, what's the process of, say, looking at a set of images and you're kind of starting to classify things that you're looking at? How do you go from that to, like, what is the ground truthing component and what is the dating component of this? And
so the trick with it is, you can imagine LiDAR of any region is just a photo, right?
Yeah.
So you can't tell anything that you don't get to verify on the ground. A really good example of this is actually not from LiDAR, but from Corona satellite imagery in Iran. Jason Orr, my undergraduate advisor, one of the things that he had done is research looking at modern satellite imagery versus this sort of 1970s Corona data, spy satellites. And Iran had this massive period of agricultural intensification where they built out irrigation in fields.
Yeah.
But if you were looking at nomadic campsites, in the modern satellite data, you only saw the campsites in the mountains. If you look in the 1970s data, under where the fields are today, you'd also see nomadic campsites down in the valleys.
Oh, interesting. Yeah.
So for the LiDAR, we're getting that now. If you were to take that in that landscape, you're getting the modern fields.
Yeah.
So you're always getting the palimpsest at the point of recording.
Right. And for example, if you had, like, say, a temple and it's actually like 3 temples layer caked, you're getting the last temple.
Yes, exactly. So the LiDAR for Caracol, because after people leave, no one really comes back and intensively uses that landscape. It gets used for logging, probably for some harvesting of materials from the jungle, and sort of low frequency, low intensity activities. What you're seeing is that sort of 700 to 900 peak. And it's been preserved by the forest canopy.
Yeah.
But instead, you're also seeing not buildings like perfectly built up, but the slump and decay of the structures kind of falling, trees ripping things up. And trees can do a lot of damage over 1,000 years.
And I imagine you're also, like you said, because of it being a palimpsest, you're getting sort of the muddiness of, like, well, what if this district or this neighborhood or this cluster of houses was abandoned 300 years before the cluster next to it, but it's the last thing on the surface, and now you can see 20 houses all together, but, like, they weren't actually contemporaneous. Yeah, how do you deal with that?
So that's where the archaeological data steps in, but I should also say, so the palimpsest, the idea is coming from medieval manuscripts where vellum and pages were really expensive. So what would happen is you would maybe write something up, and then when you didn't need it again, you could get rid of the ink, but you'd see the scratches.
Yeah.
So you can get old manuscripts.
Writing on top of writing on top of writing.
Yeah.
Yeah.
And then this process was applied to landscapes, I think, by Tony Wilkinson initially, for thinking about the process of how people use the space they're in of that built environment. But jumping back to this, what archaeology gives you is it gives you that temporal control. So while the LiDAR gives you this broad spatial control of what things look like now, you can then excavate and get detailed chronologies information. What we found is that around that 700 CE point, basically everything is occupied. The city is at its maximum extent. The city and landscape are pretty infilled. The density on the whole is about 500 people per square kilometer, but it's variable. It ranges from sort of near 200 at the edges to over 1,000 toward the city center. And that 1,000 is important because that's the threshold that Roland Fletcher puts on low-density urbanism. But when you're looking at the landscape itself in these households, you're getting that little sample. The other thing I'm really relying on for ground truthing is that there were 20 years almost of ground survey data.
Okay, yeah, so you've already got, like, a starting point, at least, for things that turn up on the LiDAR that have already had foot traffic and ground truthing to some degree.
Yeah, exactly. And without that initial ground truthing, starting a project would be much more difficult.
This is a kind of a vague question, I suppose, in a way, but I'm just curious because I've only dipped a toe into the world of Mayan archaeology. I have a general sense that LiDAR has been for like a decade or more rocking the world of Mesoamerican archaeology. But how transformative has LiDAR been?
So it's been really useful at showing that sort of large-scale landscape. I think that's where it's been most transformative. It's also been particularly transformative in forested landscapes. So in a place like the Near East or a desert, that satellite image may do you just as well as the LiDAR data, unless you want to do really detailed hydraulic analysis, or you want to look at least cost paths at a really small scale. And so there are things you can do where that space and having that fine resolution really helps. And maybe there's certain features that are really hard to see on satellite data. So the corona, it's 30 meters per pixel. And you can imagine that's great if your interest is big tell sites that are massive.
Yeah, you don't really need the fine resolution to find that then, yeah.
But let's say that you're interested instead in sort of central plains, little barrow pits where people would store materials that are maybe 3 meters wide. Then the LiDAR data is actually really helpful because that you can pull it apart. And for me, that meter resolution actually comes into play with the reservoirs. So at 1 meter resolution, can you tell if it's a reservoir or not?
Right.
Because depending on where the point is within that single meter by meter pixel, you could just see a single point instead of a 3 meter by 3 meter reservoir.
Has the scope of Caracol been expanded by LiDAR? Because that's sort of the trope that I'm used to thinking about is like that population estimates have gone way up. So the sense of the hinterland or the scale of a city or the scale of an urban area has gone up. Is that true?
So the funny thing for Caracol is that it's not increased it, it's more refined it. So for Caracol, that 100,000 population estimate also occurs in the late 90s based on just the survey on the ground and data from the core.
Yeah, the pedestrian surveys.
But the trick is the assumptions made there is that it was a sort of more concentric ring model city, and instead it stretched a little more east-west. But it didn't fundamentally change it as much. What it's done, I think, is it's allowed us to help explain what Caracol looks like to our colleagues. Because if you imagine we're pre-LiDAR, and I'm telling you that there are 160 square kilometers of agricultural terracing, how would you believe me? Like, even if I'd show you the maps, you might say, well, I don't know that those are terraces. They don't look like terraces to me. And then the other thing it does is it lets us go a little bit further. So, I've expanded where the city boundary is, and there I based it on the agricultural terraces. So there's also a fall off in population, but the terraces are really visible. If you look at Caracol on NASA's 30-meter SRTM data, you can actually see the broad outline of the city in terms of the lower slope. So the terraces have
really
reduced
cool.
the slope. Yeah. They've reduced the slope so that at 30 meters, you can see it's a little flatter. And if you look just north of Caracol, there's some other sites, and you can see the same kind of process.
Yeah.
But you'd have to know it's there to look for it because it's at such a large scale.
That's really, really cool, actually. That's fun. Just by picking the right resolution, you can get this like macro scale rough footprint of the whole thing.
Yeah, and it's really showing you, too, how much of that is an anthropogenic landscape.
Yeah.
So today, it looks like jungle. If you were walking around and you didn't know what you were looking for, you'd assume that they're just these lines of stones and all these trees.
Yeah, I remember when doing a field school in Belize, they did the classic, I assume it's a classic move of like walk all the students out to a plaza, but the students just see a rainforest and then say, ta-da, we're in a plaza. See that hill? That's a temple. See that hill? That's a temple. And we were all like, wow, but there's so much nuance, I imagine, to the construction that it would take such careful pedestrian survey to be able to distinguish.
So that initial survey project did a couple sort of detailed sampling where they actually took theodolites and measured the terraces and the change in elevation for these special units to help show how much terracing was present. And even that convinced some people, but it really took the LiDAR to push it over the edge where we could zoom in anywhere and show, there are terraces here, but also over here. And here it looks the same.
Yeah.
And it really says something, too, that this landscape, that basically this is a city that is all terraces. That in order to support that population, again, you had mentioned earlier the rainfall, everything is rain-fed. So it's the people, the agriculture.
Yeah,
and the way they made that.
It's all built that way.
It's all built that way because the way they made that work was by investing in terraces. And in fact, I think if you just do like a little cocktail napkin type calculation, there's way more energy and labor spent in building those terraces than in all of the monumental architecture. And I don't think that's true just at Caracol. I think that's true in other systems. It's just we tend to look at monumentality today and it impresses us.
Yeah.
But we look at agricultural fields and don't get impressed. Even though there's a lot of labor that goes into moving things around on a field and changing the landscape. Within the terrace soils themselves, earlier investigation in the 80s shows that they actually probably had some decomposed volcanic ash. There's other organic material. So the soils themselves are manipulated. And when they're building the terraces, it's not just that they put the wall in place. They're stripping everything down to bedrock. That's probably when they're getting stone blocks for construction, because we don't really have quarries. Yep. And when they're rebuilding the soil, that final soil horizon of decomposed limestone doesn't exist the way that you'd expect from a geologic process.
Oh, interesting.
So the soils have been churned a lot.
Yeah, yeah.
And when we initially did the LiDAR at Caracol, that 2009 project, we were working with biologists who were interested in the forest canopy.
Yeah.
So the benefit of LiDAR is it gets data not just for us, but also for others who are interested in things that...
Different layers of it, yeah.
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 Because an archaeologist doesn't really care what trees are present or the foliage counts or anything like that.
Yeah.
But they were using that, and they were actually looking, and then they decided to test, are the trees and the other vegetation on ancient terraces, how are they growing compared to trees and vegetation on unmodified landscape?
Oh, cool, yeah.
And what Jessica Hightower found is that the terraces have a statistically significant effect of increasing tree size and health.
So it's not like an untouched wilderness of a rainforest anyway, but the whole like mosaic of the distribution of species is already kind of an echo of the human construction. That is so cool.
It's actually really similar to what's happening in the Amazon as they're studying the dark soils.
Yeah.
Where it's human modification that has led to what people are looking at as a completely natural system.
Yeah, that's super cool. I wanted to close by asking, well, since you're going to be in Belize next week, what are you up to?
In terms of the investigations? Or,
yeah.
So one of the things that I was really focused on in my dissertation is trying to figure out this like neighborhood level. So when I'm talking about Caracol and those sort of social levels, I'm thinking that there's a polity level, which is above my scale of what I'm looking at within a single city. But the idea that there's a network of cities that are all falling under the same sort of state-like entity, right? Whatever that entity is, however it's managed. And then there's cities, which tend to have their own governance, their own systems. And so that city level would be the whole 240 square kilometers. But within that, what I'm then looking at is this district level of about 25 districts. And, depending on the district and the service, some of them have it, some of them don't. But that's the next sort of tier down, where you could imagine the districts may be working together when they're pushing back against something they don't like from the city hall and the downtown.
Yeah.
You can see that actually today in a lot of different cities. And I should also point out this district level is almost certainly more similar to the like census block or quote unquote neighborhood level as people would describe it today in social science. These have a population between 2,000 and 10,000 people at Caracol, roughly about 4,500 and change. And a census block is between, I think, 2,000 and 8,000. I may be getting that wrong off the top of my head, with an average of about 4,000. And that this social unit, in other contexts, you've also seen in other places, people have used this sort of 5,000-ish or 4,000 plus people as the like bare minimum where you need to provide a public park and a school. So it gets used for service provisioning, which is what I use the district for. But the term may change depending on the social context. But below that, there theoretically should be this sort of neighborhood level.
Yeah.
Now, neighborhoods don't have to exist. But the idea is if you're always walking around and you don't have the ability to go online and listen to podcasts or call your friends, that you're going to interact with people who are nearby. So your chance at meeting other people and socially interacting frequently is restricted to this sort of special unit where it's a social unit that's embedded in space.
Yeah.
And is based on this idea of common commuting times or just forced interaction. If a terrace wall needs to be repaired and you and your neighbor are sharing that terrace, however the land is managed, there's going to be some interaction.
Yeah.
And in these units, I'm then trying to look and see if I can find an architectural feature. I don't...
Okay, so sort of like a centrality or like an organizing sort of
is
feature.
there a community building? And the answer is no. There's no clear community hall. Some people have argued that for neighborhoods at other sites, but I think it's always not as clear because sometimes what they're looking at isn't like a separate community building, but maybe one larger household. And I will say, within any given set of houses, you will probably have one house that is larger than all the others. So what I did is I looked at the households on the landscape and the time it would take them to get to these different public plazas with the idea that they're interacting in the sort of space around the household in those fields, on the way to and from the public plaza and at these public plazas. So you can see these different foci where people are gathering to interact. And then looking at all of these, running it through a clustering analysis, there was a clear sort of breakpoint roughly around 373. I wouldn't treat that as an exact number, but let's say about 370 neighborhoods. Now, it's a subset of the data, so this gets really complicated under the hood. So what I should say is there are hundreds of neighborhoods, and here's a reconstruction.
It's nice for people to hear, though, like, how complicated archaeology gets under the hood. And, like, a lot of this stuff that ends up in, like, a 2-paragraph summary in, like, a Nat Geo article, there's a lot of thinking and a lot of debate and a lot of nuance, and, yeah.
Well, and for me, one of the things that I was expecting for neighborhoods is that, one, they're based on social proximity, right? So you have this sort of geography's first law, closer things are more likely to be more similar or interact more often just because of that spatial proximity. Or you could think of it as spatial autocorrelation. And then the second is, well, they're social actors. So you can picture these as people in households or households themselves and their social interactions. And what you're likely to have is people interacting in such a way that they are perpetuating this one concept. It's the principle of triadic closure, or it's also called cognitive balance. But you could picture there are 3 houses or 3 people, right? And let's say that it's April, Bob, and Susan, right? So April is good friends with both Bob and Susan, and so far Bob and Susan don't really know each other. In theory, over time, what should happen is either Bob and Susan become good friends because they're both good friends with April, and that would form a natural sort of triadic clique, or April's connections with one of those two is going to degrade over time and become a little bit weaker. And that's that principle of triadic closure, that social networks really like triads because triangles are strong shapes. And you could see that as sort of social pressure, right? If they all become good friends and Bob and Susan are going somewhere, April is probably going to go too.
Right, yeah.
Now, within the households, what I'd expect is that neighborhoods have more of these than they do between other neighborhoods. So the connections between the other neighborhoods should be that weak tie or an absence of a tie. And within a neighborhood, there should be multiple overlapping triads, which is how you form that clique. But whereas that first process of just spatial proximity, you could imagine fuzzy neighborhoods that bleed into each other and don't have distinct boundaries. This would let you have boundaries, but it doesn't tell you how big they should be. And so in the literature, you can find people who talk about neighborhoods of 5,000 to 10,000 people, which seems like a lot to me because a lot of ancient Maya cities don't hit 10,000 people.
Right.
The final one is this idea of sort of cognitive limits on interaction, that you only have so much time or energy to spend interacting per day. And if you're going to have frequent and repeated interactions, that there's this threshold which Dunbar would put at 150, but more modern research has basically said under 500. So it's sort of 500 plus or minus 100. And that's from Koss and Lindenforce et al.'s reanalysis of Dunbar. Although Lindenforce would maybe suggest that Dunbar's number doesn't exist. Because what they found is that there are multiple peaks. But all of their peaks basically fall under 520. Whereas Koss's data set is ethnographies of hunter-gatherer groups. But if you put that in, so you're now expecting that whatever you're putting out from these outputs, it should have roughly under 500 people per unit, and these other principles are based on social interaction in space. We can look at that clustering of cost distance, and that fall off around the 373 value produces neighborhoods that are all under 500 people. Or potential neighborhoods, I should say. What I then did is I tested those with the material from the Eastern shrine buildings. So the idea is if you have a neighborhood, one of the ways you're engaging in social interaction is that you're having rituals where you're inviting neighbors built around that Eastern shrine practice. And as neighbors are engaging in these practices, they're seeing what people are buying or using or how they're conducting the ceremony, and they're copying each other. And you're more likely to copy the neighborhood you're in than another neighborhood. And so looking at that, there is more similarity of materials within than between neighborhoods. What that similarity is based on gets a little weird because there's already this pan-Caracol thing of, one, doing the ceremony, often in the Eastern building, two, face caches, which are these ceramic vessels with applique features to make it look like a face, and then three, finger caches, which are these sort of little tiny, let's say, 5 centimeter to 7 centimeter diameter bowls, lip to lip, sometimes with a finger often just the tip of a finger, sometimes a whole finger, sometimes more than one finger. Mm-hmm. And these deposits are happening at sort of a cyclic time in that household's Eastern structure, so that ritual building. It's not always Eastern, but about 70% of the time to 80%. And they'd go in maybe every 20 years and you're doing another ritual. You might add a deposit. You might go back into the tomb and add another family member who passed away. You may move a family member out of the tomb. You may remove some items and put them in a different cache in the building. And so you get this series of different use patterns that are happening at sort of cycles over the whole occupation of the household. And within that data set, these spatially reconstructed neighborhoods have more similarities within themselves than between those of other neighbors, which lends idea that these might represent real neighborhoods in a social sense.
Wow.
But it's not based on a single structure.
That is awesome.
That's currently sitting in review for Journal of Anthropological Archaeology, and hopefully should be out soon. But if not, it'll just have to be a different venue.
Well, good luck with the paper review. But
thank you.
That is insanely, first of all,
it's also written up in my dissertation, so
multifactored, nuanced, but I think it lends. It's such a great example for people of how deep archaeological research goes. Well, and the amount of different things you're considering for this reconstruction,
and that's just to reconstruct the sort of neighborhood level, because beneath that I'm seeing the households that Plazuela as a single level.
Yeah.
And if you were a bioarchaeologist, you might then go into individuals and life histories as the social layer beneath that. But by reconstructing these, I can then look at each as an analytical unit. Yeah. So by showing their neighborhoods and testing them, I can then look at the differences or similarities between neighborhoods. I can look at neighborhoods like people would study districts, neighborhoods, census tracts today.
That's going to be amazing for thinking about change over time in the city, being able to look at it at that kind of a level.
Right.
That's amazing.
Although the LiDAR is giving me just that sort of last 200 years of occupation in terms of house size or volume. Mm-hmm. So it takes the archaeological data to then give that temporal depth.
Yeah. I always kind of ask a closer question like this of, are there 2 or 3 authors or particular papers or books that to you, like if people want to kind of read a bit more about the kind of stuff you study, they should look at, they should read?
So first off, all of the articles and even the season reports for the Caracol project, which is in its 37th field season this year, are available online at www.caracol.org, so caracol.org.
Awesome, and I'll include a link to that in the YouTube description and on the website. And
Doctor's Chase Publications, and that's where they're all listed. Mm-hmm. But probably the major one that summarizes the research, because it's been such a long project, is there's a 2017 article by Arlen and Diane Chase, Changing Perceptions. For my research, maybe the one of my water management ones. I have 3 different ones on there. For the terracing, it's the one with John Weisample for Advances in Archaeological Practice. And then for some of the neighborhood and other like city theory, that's coming out. So
noted.
It should be out by the end of the year, but I can't promise when, because a lot of that went into edited volumes that have taken a while.
Fair, yeah. Well, thanks again for taking the time to do this. I really appreciate it. This was really great.
I'm glad you enjoyed, and thanks for chatting.
And thank you for listening to this episode of The Tell. Until next time. Hey everybody. If you enjoyed the podcast and you want to help me talk to more people in more places, please consider donating. You can do so on my Patreon as a recurring donor, as well as on my website if you'd rather do a one-time donation. The links are patreon.com/Sebastian Weatherby and www.sebastianweatherby.com. Show notes are also available on my website, where you can find citations and comments and other relevant information about the things we talked about today. Thanks again for listening.